Hi, Timothy Unger here. This is part 8 of my late 2022 Python programming tutorial. You'll find links to parts 1 through 7 in the description below, as well as a link to the GitHub repository in the description below. I'm going to keep with my file naming conventions of the previous 7 tutorials. And so we're going to start with, we're up to number 46 here. So we're going to do 046 underscore write underscore to underscore file. Okay, so we're going to start with that. And what we're going to do is we are going to write to a file. So I'm going to create a variable f, and I'm going to set that equal to open. And then I'm going to set that to my test.html. So I'm giving a file extension. So that's the file I'm going to write to. And it's going to create it because I don't have it here. It's going to create it in the same directory when I run this program. And then I'm going to write a few lines to it. So I'm going to do f.write. Okay. And I'm going to do, I'll put in a second level heading here. Just say, this is a heading. This is HTML, in case you're wondering. And then I'll close off the second level heading, put a /n for a new line character there. And so I can bring it down and write another line. And I'm going to write a P. This is a paragraph. And close off my P tag. And we could put a /n there as well. Okay, when I open a file, it's always good practice to close it after I'm done writing to it. So I'm going to do f.close here. And I'm going to close the file. And let's run it. Okay. So you'll see that everything ran. The process finished with exit code 0, meaning there were no errors. And if you look here in the directory, we see that we have my test file.html, and you have two HTML tags here, a heading tag and a paragraph tag. Okay, so we've used that to write to a file, and we're going to use that to create a worksheet in a moment. But first, I'm going to talk about reading from a file. So now that we've created a file, we can also read from it. So I'm going to create another file, 047 underscore read underscore file .py. And what I'm going to do now is we're going to create another variable, f, and we're going to open that file that was created. So we're going to open my test.html, and we're going to, instead of writing, so I had a W when I was writing, we're going to read now. Okay. And so I'm going to say, I'm going to create a variable, file underscore lines equals f dot read lines. Okay. All right. And we're going to, after we're done reading from the file, we're going to close it. Always good practice. So we're going to close. And then I'm going to do a little for loop here. And I'm going to say for line in file lines. And what I'm going to do is print out the line. Okay. And now we'll run this. And if we scroll up, we see we get the line. This is a heading, and then this is a paragraph. So we get the lines printing out the console. So we've read from this file that we've just created. Okay. All right. Next one, I'm going to use it to create a math worksheet using this reading and writing. So let's create a new file here. New Python file. We'll call this 048 underscore create underscore math underscore worksheet .py. And I'm going to import a random module. So I'm going to import random as, and we'll import it as rand. That's a typical convention. Then I'll have to type out all of random. I can save myself 2 letters of typing. And I'm going to create a file. We're going to open a file. We'll call it math-wksht.html for worksheet. And we're going to write to it. So I'm going to give the flag that we're writing to it. And what I'm going to do now is run a for loop. I'm going to say for I in range 1 to 101 what I'm going to do is I'm going to say num1 equals rand.rand int 1 to 20, and then num2 equals rand.rand int from also 1 to 20. So these are giving me random numbers from 1 to 20 and including 1 and 20, okay? And what I'm going to do now is write to this file. So I'm going to say f.write, and I'm going to write an f string. Okay, so that way I can pass in these variables. All right, so I'm going to start with my paragraph tag, and I'm going to give a problem number. So I is a variable, and I is from 1 to 100 because the range is from 1 to 101. You don't include that last number. So this is going to be my problem number here. And then I'm going to say solve for x, okay? And I'll say x plus num1 equals num2 here. And we'll close off our paragraph here. And we also want to have a new line character here. And we'll go down here and close out the file. So we'll do f dot, and see if I do the dot, I get these different things I can do. So I'm going to close it, put a new line at the end of the file. Let's just format this file. Let's do code cleanup, run, and we are good. Okay. All right. So now let's run it. All right. So the process finished with exit code 0, so no errors. And let's open this math worksheet.html. And look at this. We've got a bunch of random problems created that we could have for our students. Now, there's no head of the HTML file here. There's no CSS styling. If you guys are familiar with web development, I haven't done any of that. I've just created the problems, but I could easily add that at the top and format this document. And if I just open this document as is, so go to Linux files here. This is, where's this, part 8? And mathworksheet.html. If I open it, I've got all these problems in the browser. And one of the things you can do, and now this is not styled, I would style this differently, of course, but I could go here, go to print, and go to more settings, get rid of the headers and footers. Okay, and now I've got my bunch of problems that I can print as or save as a PDF. So I've got my worksheet for math teachers out there. Now, for math teachers out there who happen to be watching this, I will leave a link to my Teacher Pay Teachers store in the description. That would be great if you could help support the channel that way. I do create worksheets like this, up to 100 problems, and sell them for a very reasonable cost, along with solutions. Now, I'm going to not show you how I would do the solutions as well. I don't want to give away everything, but yeah, it's very, notice how quickly I created a worksheet of 100 problems. So programming saves time. Okay. So that was a little bit of what you can do in a practical sense, or what I've used in a practical sense for writing and reading to a file in Python. We're going to start to talk in the next file, though, about creating your own packages in Python. Okay. And this will be a little bit more complicated. So I'm going to create a new Python file. I'm going to call this 049 underscore import underscore packages dot py. Okay. And what I'm going to do is, I'm also in this directory, I'm going to create a new directory called my package. Okay. So now I've got a directory called my package. Within my package, I'm going to create a new directory called, let's call it subpackage, or package feature. Let's call it package feature or feature. And also within this package here, let's create, in the my package, let's create a main.py. Okay, we need that. And then moving into the feature, the package feature, let's create a new Python file. Let's do a dunder init file. which is something we'll run dunder_init.py. This will run if you access any of the files within this package feature. Okay. And let's also create a new Python file in here. Let's call this copyright. Okay. And let's just say, let's create a variable called copyright date. And I'm going to do this and kind of show you, and you can kind of get a feel starting to play for this, how this is going to work. And then we can say this is the init file, just to show you that the init file will be called the dunder_init file. We can print something like this. Now let's just say dunder_init.py executed from, and then I'm going to do an escape character here, from what is this, package feature. I can spell from package feature, do another escape and a quote there, double quote, folder. Okay, so this is going to just show you that this is running from this subfolder here. Okay, so now if I go into my package and go into the main here, okay, what I can do is I can import various things. Okay, so let me go to my main here. I'm going to say from package feature import, let's import the copyright. Okay, and now that I've imported that, and if we go back to the copyright here, we see we have a variable copyright date. And so now, just showing you how you can import various things within your package, I could print, use an F string and say, this package's copyright date is, and we'll pass in, we'll do copyright dot copyright date. Okay. And then if I want to run this file, you'll see that we have this package's copyright date is 2022. So we've pulled that in. And we also see that the dunder_init.py is executed from the package feature folder. So because I imported copyright, which was in the same folder as the dunder_init, the dunder_init is executed. Okay. Within this package feature folder, we could create, let's create a new directory. And let's call this sub package or package sub feature. Let's package sub feature. Okay. All right. So now we've got this other folder, package sub feature, in here, and then within that we could create a dunder_init. So let's create a new Python file. So create a dunder_init.py within there. And what I'm going to do is just do, we'll print a string and say, I'm going to say dunder_init.py executed from, let's do an escape character, and we're calling this package sub feature folder. Okay. All right. So we've got that. And now with also in here, let's create some number methods here. So we'll do a new Python file, and we'll create some number methods within this. Okay. Number methods.py. And within our number methods, I'm going to come up with some different functions. So let's create one called exponent. We'll take in a num, and actually no, we'll take in a base and a power, and we'll return the base raised to the power. Okay, so that's one we could do. Let's also create a circle circumference. Call it circle underscore circumference. Not doing camel case, do snake case. And we'll take in a radius here. And we're also going to go in here in this package, we're going to import math. Okay, so we can do that as well. And what we're going to do here is we are going to basically the circumference is 2 pi r, so we'll return 2 times math.pi times the radius. Okay, and we could go down, we could create let's create a circle area. Also take in the radius. Or actually, no, let's take in the diameter, because that's twice the radius, right? So let's mix it up a little bit. And now the circle area formula is pi r squared. So what we really want to do is return math.pi times, let's do the diameter divided by 2, that gives me the radius, raised to the second power. Okay, so that's my circle area function. Okay. All right. Let's just do a little code cleanup here on this file. Cool. Okay, giving me a little spacing. And let's move this out here. Okay, go back to my main.py here. And what we can do is we can also import from the sub feature. So we could do something like import, and then we do something like package feature dot package sub feature dot number methods, and we can give it an alias. So as, let's do num. Okay, and now what we could do is we could print something out. So we could print, let's do an f string and say 3 raised to the second power is, okay, and what we're going to do is we're going to do num dot, okay, and we're going to use the exponent function here, and we'll do 3, 2, because 3 is the base. Okay, we could also print something like a circle with a radius of 5 has a circumference of, and I'm just going to make some room here. So we'll do circle, or actually first we have to do num dot circle circumference and pass in the radius. And finally, we could also, let's do another print, do an f string, a circle with a diameter of 12 has an area of, and what we can do is we can do num dot circle area, pass in 12. Okay, let's run this file. And we see that we get the 2 dunder inits, the one from the package feature and the package sub feature folder. Those are executed. Package's copyright date is 2022. That's this line here. 3 raised to the second power is 9. That's correct. A circle with a radius 5 has a circumference of 31.4, blah, 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 blah. We could round that if we wanted to. A circle with a diameter of 12 has an area of 113.097, etc., etc. Okay. All right, let's bring back the project here. And let's see. So we've got that, the my package. Now let's go back to 49 here, file 49. And what I'm going to do now is start to import stuff in file 49. So what we could do is import my package dot package feature dot package sub feature. Let's make some room. This is a lot. Dot number methods as, let's say, num. Now what we could do is we could print let's say 5 raised to the 6th power is, and then we can go here and we can do num dot exponent, pass in 5 and 6, and do a period here. And we can run this, and when we run this, we get the init stuff. We could take that out and not have that run if we wanted to. But we get 5 raised to the 6th power is 15,625. So basically what this is showing you is this is calling from file 49, from file 49 here, this is calling all the way down into this number methods here. So we are importing this package, okay? What I also want to do is create a my other package. Let's just go through that. So we're going to go up here. Let's create a new folder, new directory, and we'll call this my other package. And we're going to make this a little bit more streamlined. So my other package, okay? And then within my other package, we're going to create a new directory. Let's call this numbers. Okay. We're also going to create, we're not going to create anything inside of this. So we're not going to create a main inside of this for this one. Inside of here, though, we're going to create a dunder init.py, and we're going to create a, what am I doing here? Sorry, my bad. I do want to create an init.py in here, but I also want to create one in the outside one. So let me do that. So we're going to create an init.py in the outside one, as well as, no, I think that's all we'll do there. And inside the numbers, let's create a number methods.py. Okay? Because I want to streamline this and I don't want to make the video too long and spend too much on this, but we're going to create a number underscore methods here. And within that, let's import math. And then we'll create a function, exponent, takes in a base and a power, and we'll return the base raised to the power. So we're creating these functions. And let's create something different. Let's create a square function, takes in a number, and just squares it. So it returns num squared. And let's create another one, a cube function, takes in a num, and returns the num cubed. Okay, so some basic ones there. All right, so we got that. What else? Just want to make sure. Okay, so in this initial init, what we're going to do here is we're going to use some dot method. We're going to do from dot number methods. Notice it gives me that import, and we're going to import everything. Okay, so that's the star. We're importing everything. And then we're going to go here, and we're also going to do that. We're going to do from, we'll do dot numbers, import, and again, everything. Okay, so now what I'm going to do is create a file on the outside here. So let's create a file in this larger structure. Let me collapse some of these. So we'll create a file here. We're going to call this, we're still doing importing of packages. So let's call this 050 import packages. And we're going to say from my other package. Now we could import specific things, but I want to import just everything. Okay. And now what I'm going to do is in this file, it's way outside this other package. I'm going to do a print and an F string and say a circle with a radius. No, actually, I didn't do that function. Let's say 9 squared is equal to, and here I'm going to start to type it square, and you'll see it pops up. So this is coming, my IDE is telling me this is coming from my other package, .numbers, .number methods. Okay, so I want to use this, here, and I want to pass in 9. Okay. And I could also use the cube function. So I could print f and do 3 cubed is equal to, and now again, I'm going to start to type cube and look at where it's coming from. My other package, .numbers, .number methods. Okay. Cube, and we'll pass in 3. And now let's run these. And we get 9 squared is equal to 81. 3 cubed is equal to 27. So that's pretty cool that you can create a package in Python and then import it into other files. So you can have these subdirectories that you create and organize your files with, as well as just regular folders or regular files that you import files. So you can get quite complicated with your project and create a whole bunch of functions in Python. So that's pretty cool. Okay. We're going to shift gears a little bit and talk about Lambda expressions next. Okay, so I'm going to create a new file here, a new Python file. I'm going to call this 051 lambda underscore expressions .py. All right, so let's do a multi-line comment here and say that lambda expressions, these are like anonymous functions in JavaScript. You can assign these to variables, and they are good for functions you only need to use once. Okay, so let's go down here and we can say something like, let's create a variable. We'll say y equals lambda. We're going to take in some parameter, so let's call it x, and we're going to square x, so we'll do x times x. Okay, so that's my lambda function saved as a variable. So what I could do here is print y and then pass in 3, and this is going to output 9. It's going to square 9. So if I run this, I get 9. Okay, pretty nice. We could create another one. Let's give it a different name. Let's call it QB. All right, and we'll do lambda, and we'll take x in as parameter. We'll take x and raise it to the 3rd power. We'll cube it. Okay, so now what I could do is I could print QB and pass in 3, and 3 cubed is 27, so that's going to output 27. So if we run this, we get 9 and 27. Okay, so that's the start of Lambda expressions. Now let's talk about using Lambda expressions with map. Okay, so I'm going to go here, create a new Python file called 052, and we'll call this lambda underscore with map. Okay, and what we're going to do is we're going to create a list so we can use the map, and the list will be 1, 2, 3, 4, 5. Shout out to Spacewalls fans. And what we're going to do here is we're going to print the map, and for the function, so we give a function now and we give the list for the map function. So I'm going to give a lambda function. So I'm just using this one. So lambda, taking a parameter of x, and let's square it, and we'll pass in the nums list. Okay, so if we print this out, we see we get a map object. Okay, and if you remember from the previous video, to convert a map object into a list, we just have to use the list keyword and wrap it in the list keyword. So we'll wrap it here, and let's now run it. And you'll see we get 1, 4, 9, 16, 25. So we've taken that list and we've squared every value within the list. Pretty cool. All right, we can also use lambda with filter. So let's do that. Okay, so what I'm going to do now is create a new Python file. We'll call it 053 underscore lambda underscore with filter .py. And we're going to create a nums list, but this time I'm going to make it larger. So what I'm going to do is I'm going to unpack a range here. So do an asterisk, and then the range, and we'll do from 1 to 101. And what I'll do just to show you that this is a long list, so let's just print it out. So we see we get 1, 2, 3, 4, blah, 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 all the way up to 100. Sweet. All right, so I'm going to get rid of this, and we're going to use filter, and we want to filter it into a list. So we're going to wrap everything in a list. Then we're going to use filter. Okay, then filter takes in a function and a list. So we'll do a lambda function. We'll take x, and we'll say if x divided by 3 equals 0. So think back to fizz. So this is, let's say, my fizz list. Okay, and we'll pass in nums. Okay, so this will be my fizz list. All the numbers that are divisible by 3 from 1 to 100. Let's print it. Let's run it, and we see we get 3, 6, 9, 12, 15, 18, etc., all the way up to 99. So that's using filter with lambda functions. That's pretty cool. All right, next thing I want to talk about is reduce, which I haven't talked about yet. So let's talk about that, and then we'll talk about using reduce with the lambda function. So we'll call this 054 reduce. Okay, and we'll go to reduce here. And so first thing we want to do is we want to import func tools, and specifically from func tools, which is a module, we want to import reduce. So we could do from func tools import reduce. Okay, notice I'm getting those suggestions from my IDE, which is pretty nice. And we'll go down here and let's create a function, and that creates a sum. And now typically with reduce, you have an accumulator and an item. Okay, and then you can return, or you could use X and Y. I used X and Y for the GitHub thing, but I'll just use return accumulator plus the item. And let's see what's going on here. So let's create a nums list, and it's going to be 1, 2, 3, 4, 5 naturally. Okay, and let's say we want to add up the sums list. Well, what we can do using reduce, if we want to print the sum, is we could print use reduce. That takes in a function. So we're going to take in the function sum. We're not going to call it, but we're just going to give it the function, and it's going to be applied to the nums list. And so what this is going to do is this is going to run through, and we're going to start with 1, and we're going to add 2. Okay, then we're going to get 3. So that's going to be my accumulator. Then we add the item 3. So 3 plus 3 is 6. So now this is my accumulator. And 6 plus 4 is 10. And 10 plus 4, or 10 plus 5 is 15. So we should get 15 running this. Okay, so we get 15. Sweet. Now let's create a few other functions just to show you this. So let's create a subtractor. Okay, this is probably less common. So we have accumulator and an item, and what we're going to do here is we're going to return the accumulator minus the item. Okay, and so we'll go down here, and what we'll do is we'll run reduce, run the function subtractor without the parentheses, and then pass in the nums. And you notice here, we're not going to get negative 15, we'll get negative 13. Well, why is that? Okay, well, let's run through our nums list. So we start with 1. Take 1 and subtract 2, we get negative 1. So that's negative 1 now. Negative 1 minus 3 is negative 4. Negative 4 minus 4 is negative 8. So the first 4 numbers, we got negative 8. And then negative 8 minus 5 is negative 13. Okay. One last one I want to show you is, let's create another one called multiplier. And we'll have accumulator and an item. And what we'll do is return the accumulator times the item. Okay, and so now let's do it to the list. So we'll print reduce, and we'll do the multiplier. And again, without parentheses, and then the nums. Okay, so we run this, we get 120. Okay, because we start with 1, we do 1 times 2, which is 2, 2 times 3, which is 6, 6 times 4, which is 24, 24 times 5, which is 120. Notice this is similar to a factorial. Factorial, you do 5 times 4 times 3 times 2 times 1, but you're basically doing the same thing in reverse. Okay, so that's reduce. And now let's use a lambda function with reduce. All right, so let's create another file, 055. So new Python file, 055 underscore lambda underscore with reduce. Okay, and what we're going to do is we're going to import. So we'll say from functools import reduce. And then what we'll do is create a nums list. We'll just say 1, 2, 3, 4, 5. And now we'll use the lambda expression. So we'll print, we'll do reduce. Okay, the function will be a lambda function. We'll take in a parameter x and y, or another way to think of this is accumulator and item. Okay, and then what we're going to do is we're going to return, or the function is going to return the accumulator plus the item. Okay, and we're going to run this for the nums list. Okay, so what is this going to do? This is going to add everything up. Okay, and we get 15. Okay, we could also do our subtraction function. So we could do reduce, do a lambda. We take an accumulator and an item. We return accumulator minus the item and pass in the nums list. Let's run this. We get minus 13 like we did before. Finally, we could do our multiplier. So we do reduce, and we do lambda, take in an accumulator and an item, and then we return the accumulator times the item. And we use the nums list, and we run it. We get 120, just like we did with the multiplier. Okay, so that concludes part 8 of my Python programming tutorial. Thank you for watching. If you did like this video, please give it a like and consider subscribing, as it really does help the channel grow. And I'll see you in the next one. Have a great day.